Hello friends, welcome to Learner's Planet. Friends, this is our 10th session for progression in series. In the previous session, we discussed some important problems where we had to find out the sum of the series. Some specific series were given and we had to find out the sum. In this session, we'll be discussing more problems, more concepts. So just get ready with your paper and pen and let's begin the session. Now we have this pattern of problem. Find the sum to 7 terms of the sequence. Now here you can see the first term is 1 upon 5, 2 upon 5 square, 3 upon 5 cube, and the second term is 1 upon 5, 4, 2 raised to 2 upon 5 raised to 5, and 3 upon 5 raised to 6. So this 1, 2, 3 is common everywhere. So what we can do, we can break up the terms, we can break up the 3 terms or maybe all the terms as 1 upon 5 plus 1 upon 5 raised to 4 plus 1 upon 5 raised to 7. This is the first breakup. Then 2 can be taken as common. Again 1 upon 5 square plus 1 upon 5 raised to 5 and so on. Again the third term, 3 can be taken as common. 1 upon 5 cube plus 1 upon 5 raised to 9 and so on. Right? So precisely we want 7 terms. So we'll find out the sum of this sequence to 7 terms, this sequence to 7 terms, and this sequence to 7 terms. Now the problem becomes very easy. It's a geometric progression. This, and this, all of them are geometric progression. So what is the sum of a geometric progression for 7 terms? It's a1 minus r raised to n upon 1 minus r. Since in all the 3 cases a common ratio is less than 1, we'll be using this formula. Okay, so a is 1 upon 5 over here. 1 minus r will be this divided by this, so that is 1 upon 5 cube raised to 7 upon 1 minus 1 upon 5. Right? Similarly over here the first term is 1 upon 5 square. The common ratio will be 1 upon 5 cube. This the same thing. The numerator will be just 1 minus 1 upon. The common ratio is further here. It is r cube. I'm sorry. So it will be 5 cube. Over here also the common ratio will be 1 upon 5 cube. Okay. So we just have to find out the sum till 7 terms. This and this. So precisely this thing will remain same. Okay, so just find out the sum and you can simplify. I'm not going to do the entire sum over here. I have just shown you how to proceed now. Okay, now this is going to be something important, very frequently asked in exams. Okay, so 5 plus, we have to find out the sum. 5 plus 5 5 plus 5 5 5 till n terms. Okay, so what is the first step? Take 5 as common, the number as common. So you'll be left with 1 plus 11 plus 111 till n terms. Okay, next is we'll multiply and divide the entire sequence by 9. So 5 by 9, it is 9 plus 99 plus 999 till n terms. That really doesn't matter which number is here. It may be 7 plus 77 plus 777 and so on. So what you have to do, whatever is the number over here, that has to be taken common. Then this will be the sequence. Then you have to multiply and divide by 9. Now this 9 can be written as 10 minus 1. 99 can be written as 10 square minus 1. This can be written as 10 cube minus 1. So the nth term will be written as 10 raised to n minus 1. Okay, now you are getting the sequence 10 plus 10 square till 10 raised to n minus 1 1 1 till n times. So 1 for n times, it will be n only. Okay, now this becomes very simple. 5 by 9. This is a geometric progression with the common ratio 10 and first term also 10. So a r raised to n, r is what? 10 raised to n minus 1 upon 10 minus 1, that's 9 minus n. Okay, so this will be the sum of this sequence. Okay, if you just go for the LCM, you can simplify. 10 into 10 is to n minus 1 minus 9n by 9. So this 9 and this 9, when they are multiplied, it will get 81. But this is the way to solve this problem. Okay, if it is 9 over here, if it is 8 over here, if it is 7 over here, so accordingly you need to take the number as common. I hope you are clear. Now this sum is quite similar. Here S is equal to 0.7 plus 0.77 plus 0.77 and till and term. Okay, so what will be the first step? Just take, you just do one thing. It is 7 by 10 plus 77 by 100 plus 777 by 1000 and so on. Okay, so here the third term 10 cube, so last term it will be 777 n times by 10 raised to n. Okay, n times by 10 raised to n. So what I do, I take 7 as common, so here I'll be getting 1 upon 10 plus 11 by 100 plus 1 by 1000 and so on. Okay, again I'll be doing the same thing. I multiply and divide the expression by 9. So 7 by 9, it is 9 by 10 plus 99 by 100 plus 999 by 1000 and so on. Okay, now 9 can be written as 10 minus 1 and this is by 10. So 10 minus 1 by 10, so 10 minus 1 by 10, so this. Okay, plus 100 by 100 minus 1 by 100. Okay, similarly 1000 by 1000 minus 1 upon 1000. Okay, so it is 7 by 9, 1, this is 1, 1, 1 for n times, so 1 n times, so I can write it as 1, minus, I can take minus as common, so I'll be getting 1 upon 10 plus 1 upon 100 plus 1 upon 1000 till 1 upon 10 raised to n. Okay, now this is 7 by 9 and minus, now we are having a geometric progression with the common ratio 1 by 10. So first term is 1 by 10, 1 minus r is the common ratio, that is 1 by 10 raised to n upon 1 minus 1 by 10. Okay, you just simplify it, you'll be able to get the final answer. Okay, whatever the formula I have used, 1 minus r raised to n upon 1 minus r, because r is less than 1 over here. Okay, so this is the standard method to solve this problem. This one where we are having the decimal before the numbers, and in the previous one there is no decimal, right? So the method is quite similar. First of all, just remove the decimal and write down the expression, then multiply and divide by 9 and proceed. Okay, sum the following geometric series to infinity. Now you should be able to observe that it is a combination of two infinite series. This is the one series and this is the second. So you just write down like this, 1 upon 2, 1 upon 2 cube and so on, plus 1 upon 3 square plus 1 upon 3 4 and so on up to infinity, right? So what will be the sum of this? Sum of infinite geometric progression is a upon 1 minus r, where a is the first term, r is the common ratio, it has to be less than 1. So first term over here it is 1 by 2 and 1 minus r, common ratio is 1 upon 2 cube by 1 upon 2, so that is 1 upon 2 square, or I can say 1 by 4, right? Here the first term is 1 upon 3 square, 1 minus r, r is again 1 upon 3 square, or I can say it is 1 by 9. Okay, so it is 1 by 2 upon 3 by 4 plus 1 by 9 upon 8 by 9. Okay, so it is 2 by 3 plus 1 by 8. 8 2s are 16 plus 3 and 19 by 24. That will be the sum of this sequence till infinity. Pretty simple. Now let's see this one. Here we can see both of them are arithmetic geometric progression. The numerators are in arithmetic progressions and denominators are in geometric progression. So I just write S is equal to 1 plus 3 by 2 plus 5 by 4 plus 7 by 8, and the nth term will be 2n minus 1. This is 2 raised to 0, 1, 2, 3, that means it is 2 raised to n minus 1, right? For nth term power will be n minus 1. So this is what the nth term. Okay, now what I do, I multiply s by 1 by 2. That means precisely I am dividing s by 2, and I am just shifting to one step. So it's 1 by 2 plus 3 by 4 plus 5 by 8, and it is 2n minus 1 by, I'm sorry, it will be 2n minus 3 by 2 raised to n minus 1, then plus 2n minus 1 upon 2 raised to n. When this term is multiplied by n, you will get this. Okay, now if we deduct this from this, s minus s by 2 is equal to s by 2. Okay, then this is 1 plus 2 by 2 plus 2 by 4 plus 2 by 8, and if this is deducted by from this, 2 upon 2 raised to n minus 1, and this is 2n minus 1 upon 2 raised to n. Okay, then 1 plus, this is 2 I can take common. In fact 2 by 2 I can take common, so it is 1 plus 1 upon 2 plus or instead what I do, 1 plus 2 I take just common, so it is 1 upon 2 plus 1 upon 4 plus 1 upon 8 till 1 upon 2 raised to n minus 1 minus 2n minus 1 upon 2 raised to n. Okay, now this is what a geometric progression with n minus 1 term. It is starting from 1 and going up to n minus 1. So there are n minus 1 terms. So we can find out the sum. Here r is the common ratio, that is 1 by 2. So it is 2, a is 1 by 2, 1 minus 1 upon 2, that is r raised to n minus 1 because the total number of terms are n minus 1 only, upon 1 minus 1 by 2. Okay, minus 2n minus 1 upon 2 raised to n. Now this is 1 minus 1 by 2 is 1 by 2, and this 1 by 2 is cancelled. So s by 2 is equal to 1 plus 2, 1 minus, this is 2 raised to minus n minus 1, or we can say 1 upon 2 raised to n minus 1 minus 2n minus 1 upon 2 raised to n. Okay, so s by 2 is equal to 1 plus 2 minus 2 upon 2 raised to n minus 1 minus 2n minus 1 upon 2 raised to n. So it is 3 minus, you can write it is 2 upon 2 raised to n by 2. So it is 2 minus 2n minus 1 upon 2 raised to n. Okay, so this is what is s by 2. So s will be 6 minus 2 cube upon 2 raised to n minus 2n into 2, 4, or we can say 2 into 2n minus 1 upon 2 raised to n. Now we can take LCM, or from these two steps you can take 2 raised to n as common, and the remaining calculation will be inside the bracket. So this is how we can find out the sum of an arithmetic geometric progression. Now how would you verify whether this is correct or incorrect? So we know if we put s is equal to 2, right, that then the n is equal to 2, I'm sorry, so we'll be getting the sum of 2 terms. So sum of 2 terms is what? 1 plus 3 by 2, that is 5 by 2, right? Just put n is equal to 2 and just see whether you are able to get 5 by 2 or not. Okay, so it is 6 minus 8 upon 4 minus 2 into 2 2s are 4 minus 1, 3 by 4. Okay, so it is 6 minus 2 minus 3 by 2. So 6 minus 2 is 4, 4 minus 3 by 2, 4 2s are 8 minus 3, that is 5 by 2. Okay, so what we want? 5 by 2, and we are getting 5 by 2. That means our calculation is correct. Okay, and that's really important. I have done this one for you. In the similar way you can do this one. Okay, just be very careful in making calculation, in writing down the steps. Okay, now we have this problem. Find the sum of following series to n terms. So first of all, let's find out the nth term. Nth term will be, see, for third term we have the cubes up to 3. So for nth term we'll be having the cubes up to n. Okay, and this is 1 plus 3 plus 5 till 2n minus 1. Okay, that is what the nth term is. Now 1 cube plus 2 cube till n cube, that is n plus 1 by 2 whole square, right? And 1 plus 3 plus 5 till 2n minus 1, that is an AP with common difference 2, so we can find out the sum. How many terms are there? So it is nth term is 2n minus 1, or we can nth term is 2n minus 1, 1 plus n minus 1 into d. Precisely, we can directly write down the sum of first n odd numbers. These are first n odd numbers. So sum of first n odd numbers is actually n square. We can calculate it this way: n by 2, 2 into a plus n minus 1 into d. Okay, so if you solve this, you'll be able to get n square. That is 1 plus n minus 1, 1 and 1 is cancelled, so it is n square, right? So this is what the nth term is. So nth term is n square, n plus 1 whole square by 2 square and by n square. So this will be here. So precisely n plus 1 whole square by 4, this is the nth term. So we can take the summation to find out the sum. 1 by 4 sum of n square plus 2n plus 1, so it is 1 by 4 sigma n square plus 2 sigma n plus sigma 1. Sigma n square we can put the value, sigma n we can put the value, and sigma 1 will be n. So you can get the final answer very simply, easily. Now in the previous session I have already explained how to solve these sort of problems. Here you can see 1, 2, 2, 3, 3, 4 and n plus 1. So the difference is 1. So directly this can be written as 1 upon 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus 1 upon n minus 1 upon n plus 1. So all these will be cancelled except 1 minus 1 upon n plus 1. So that is n plus 1 minus 1, n plus n upon n plus 1. That will be the answer to this problem. Here the difference is 2, 1335. So just divide and multiply the entire expression by 2. So 1 upon 2, it is 2 upon 1 into 3 plus 2 upon 3 into 5 and so on. So it is 1 minus 1 upon 3 plus 1 upon 3 minus 1 upon 5 and so on. And nth term will be 2n minus 1, 2n plus 1. Okay. Similarly, here the difference is 3. So 1447. So just multiply and divide the expression by 3. Then you can write 1 by 1 minus 1 by 4 plus 1 by 4 minus 1 by 7 and so on. You just have to find out the nth term. That's it. Okay. Similarly here, divide and multiply by 5. So these sort of problems can be done very easily. Method to find out the number by which you have to multiply and divide I have already explained in the previous session. Okay. So, and I have telling you shortcut. So when you calculate, you should verify whether you are getting the correct number or not. Okay. And other sort of other problems also I have explained in very well manner. This problem I have already solved. 3 plus 7 plus 14 plus 24 plus 37. This can be solved. You can see this 3 plus 7 plus 14 plus 24 and minus 1 term plus nth term. This is the sum. Now I just write down the sum once again. You can see the difference, that is an arithmetic progression, right? So simply you just write down the sum once again and shift them, leave the first place blank, right? Here it is 3 plus 7 plus 14 and here tn minus 1 plus tn. Okay, so whenever the difference is in arithmetic progression, the same steps you have to follow. Now s minus s is 0, 3 as it is, then this is 4 plus 7 plus 10, and here it is tn minus 1, and this is minus tn, because we are deducting this step from this. So it is tn, we can take this side. Tn is equal to 3 plus 4 plus 7 plus 10 till tn minus 1. Now this is not the part of this arithmetic progression. From this place, from 3 to tn, right? So from 3 to this place there are n terms. Okay, so if we leave 3, we'll be left with n minus 1 terms. So that should be clear in mind, clear in your mind how many terms are there. Okay, so from 3 to this we are having n terms. So if we drop 3, we'll be left with n minus 1 terms. Okay, so tn is equal to 3 plus, we have to find out the sum of these n minus 1 terms with the common difference 3 and the first term as 4. So n minus 1 by 2, 2a plus n minus 1 minus 1, n minus 2 into d, that is 3. Okay, so 3 plus n minus 1 by 2, 8 plus 3n minus 6. Just solve it, you'll be getting the nth term, and after that you need to do the summation. Okay, so that's very simple. I hope you are clear. Just multiply, take LCM and break them up and take the summation of individual term. Okay, so good number of examples based on arithmetic geometric progressions we have done. I hope now you are clear with this concept, and you should practice well with this sort of series. Okay, bye bye.